Alright guys, in this class we're going to talk about perimeter and area. What is the difference between these two concepts? Perimeter is going to be the boundary that surrounds an object, and the area is going to be what's inside the object or shape. So what's going to be inside of the shape, that's going to be the area. And it's going to be measured in square meters, square feet, square inches, square centimeters, whatever you want, whatever unit you want, but it has to be squared. And the perimeter is going to be basically just the length of all the sides. And for example, if you have a farm, the boundaries, the wood that you would use to keep those chickens inside your farm, that's going to be the perimeter. And how much field you have inside of your farm, that will be your area. Now let's talk about perimeter. And let's say that we have a polygon where we have all of these sides. Do you see the polygon? It's this one. And all you have to do is just add all the sides. That will be your perimeter. That's it. That's all you do. But what happens if you have a rectangle? What happens then? Well, a rectangle, it's basically having different sides. I mean, you got two sides that are the same. This side and this side, they're the same. And this side and this side, they're the same. So we can just add them directly, or we can use this formula, which is better because it's just going to give you this. And this formula is the shortcut. That's the whole purpose of mathematics, to make things faster. So you have a length which is 5 feet. This is the length. It's longer than the width. So this length of 5 and this width of 4.3, you can add them. You can do 4.3 plus 4.3 plus 5 plus 5. That would be the perimeter as you did over here. But you can just multiply this times 2 because you got two of them. And this, you can also multiply it by 2 because you got two of them. That's where you get this formula from. Alright, so all you have to do is just multiply times 2 the length and times 2 the width. Add that, and that's going to give you your perimeter. What about the square? Well, you have 4 sides. You can add the 4 sides directly. Go ahead, do it, add it. But you can do it faster with multiplication. All you have to do is just multiply one of the sides times 4. Now let's go to a regular octagon. This regular octagon has 8 sides. So you can just add all of those 4 sides like a caveman, just adding everything, or you can just multiply. Multiply times 8 because you got 8 of them. Now let's go over here to another concept that is also about perimeter, but now not a polygon. Now it's going to be a circle. And when you're talking about a circle, we don't call it the perimeter anymore. We call it the circumference. That's why that's the way we call it. We don't say perimeter, but it's the same thing as the perimeter. What's around the circle? Okay, so it's like what you put around a pie. It's, when you have a pie, I'm going to put a pie in a second, like this one. Imagine the pie having a crust. The crust there is going to be the perimeter, the circumference. That's what we call circumference, guys. It's the perimeter for the circle. Alrighty, so we got this formula, which is circumference equals pi times diameter. That's going to be basically all the process that you need to follow. You got to multiply your pi times the diameter. And you know what the diameter is, right? The diameter is going to be the longest length inside a circle that passes through the center of your circle. And this diameter is, of course, the double of the radius. There's going to be a formula that involves the radius, and I'm going to show you that formula in a second. So all you have to do is just multiply the pi times the diameter. You got to use 3.14. That's going to be the number that you're going to use. You don't need to use more decimals. That's going to be it. And if you want to use fractions, like in this case, you can change it to 3 and 1/7. That's going to be the approximate value of pi when you have a fraction. That's going to be the smallest, bestest approximate that you have in fraction form. So that's going to be the equation you will use to get the circumference when you have the diameter. Now, what if you want to know the circumference when you know the radius? When you only have that number, what do? Well, what you have to do is just multiply that radius times 2. That's why this formula changes to 2 times pi times the radius. As you can see from the previous formula, it's pi times diameter. The diameter is the double of the radius. That's why this 2 appears here. That's what that means, okay? Now this number pi, it's a very basic number. It's a number that is intrinsic to nature. You have the pi here in this formula, you have the pi over here. We're going to be using it a lot. But where does it come from? The 3.14 isn't just a number that somebody came up with it and they said, oh, I'm just going to bother students with this number, this huge number. You know what? It has a purpose. And the place where it comes from, it's going to be very easy to understand. It's going to be, understanding pi is as easy as a piece of cake. It's very easy, guys, to understand it. How do we get it? Well, we got 3.1415926 and so on and so on. This number has no end. It is, in a certain way, infinite in its decimals. It's an irrational number. And that's what we call irrational numbers. You're going to talk about rational numbers later on. But this is just a preview of what an irrational number is. That number has no end. And it's a very curious number because it's based on the properties of the circle. So this number isn't just a number that some teacher developed or came up with it. It is very meaningful. And in some other classes, you may have numbers like, for example, the date of the revolution, for example, or the date of whatever. Those are very arbitrary numbers. I mean, what if it would have happened in some other year? Have you ever thought about that? But mathematics is universal, and this number would work in China. It's going to work also in the US, in other parts of the world. But you know what? It would also work with other beings from other planets. I mean, this number is universal. It's everywhere, guys. This number, it's not just for humans. It's, if you go to Mars and there are aliens or something in there and they do mathematics, they're going to understand pi. They're going to understand this, guys, because it's based on the properties of the circle, guys. Basically, what pi is, when you divide the circumference by its diameter, how many times it fits the diameter inside the circumference, that is pi. That's what it means. Now, that may be a little bit difficult to understand, but let's go through an example. Let's say that we have the diameter and we make a string. Let's say that this circle is a Coca-Cola can. And we put we put a diameter with a piece of string. We measure it. That is going to be a piece of string passing through this part to this part of our Coca-Cola can. Now let's say that string, we're going to put it around the circumference. So it's not going to cover everything, it's just going to cover part of it. And how many times it fits around the circle? You know what? It's going to be 3 times. And guess what? It's not just going to be for the Coca-Cola can. It's also going to happen for the wheel of your car. It's going to happen also for the circumference of the sun, of the moon, or any other circle that you can imagine. When you take the diameter of that circle, doesn't matter what it is, take that diameter. You know what? It's going to fit 3 times around that circle. And you know what? There's also going to be another special thing. It's going to fit 3 times, but also there's going to be an extra leftover. And you know what that leftover is? It's the 0.14159 that you guys know of. And it's actually all of this. Isn't that crazy? It's wild, guys. Mathematics is crazy, guys. Let's continue. Let's go with area. Now, how do we get the area of a rectangle? The area of a rectangle, it's going to be, for example, let's say that we have a rectangle like this one, or the area of anything, it's going to be basically the same, okay? Basically, it's counting how many squares you have inside this shape. So this is going to be a rectangle. You can count all of those squares. You can count them all like a caveman. You're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and so on and so on. You know what? You got 28 there. How do you know that? Because you got 7 squares here, but you have 1, 2, 3, 4, 4 rows, and 4 times 7 gives you 28. That is going to be the area for your rectangle. Alrighty, so imagine that you have a classroom and you got your tiles are your classroom. Remember your classroom? Oh, of course you do. And you're missing it right now. Of course you are. Anyways, let's imagine that you have your classroom and you have your tiles and you want to count how many tiles you have. So when you count the amount of tiles, that's going to be the area of your rectangle. Alrighty, so let's see another example. For example, let's say we have a square. How do you get the area of your square? Well, basically it's the same as the rectangle, but the difference between the area of the rectangle and the square, it's that since we have the same sides, you don't do side times side. You can put it in mathematical notation as an exponent, which is a square. So when you place it like that, that's the shortcut to represent length times width, but when both of them are the same, you place it as side squared. So for example, here you have 6 and 6 on the sides. How do you get the area for that? It's 6 times 6 gives you 36. That's great. Now let's do something more challenging. For example, what if they give you the area of a rectangle? It's going to be 312. So let's say that this area, it's now going to be 312. Now the question is, what is the width of the rectangle if you know the length of the rectangle, which in this case is 12? So we have the area, which is length times width. How do we get the width? What do we do, guys? What do? We gotta do length times width equals 312. That's gonna be the area. But we don't know the width. What is it? What is that going to be? We're looking for a number that when you multiply by 12, it gives you 312. Now you may be guessing inside your little head, what's going on here? What number do I use? You gotta check 12 times what number gives me 312? Guys, no. You don't need to go through that. You don't need to test numbers to see which one gives you 312. What you need to do is apply your knowledge of algebra. So you know that this thing is multiplying. What is the opposite of multiplication? Division. So you got to divide your 312 by your 12. Of course, that's going to give us 26. That's what you do. So when you're looking for area, you got to multiply the two numbers. But when you're going backwards, when you're looking for one of the widths, you do the opposite. You do division. That's what you get in that result. That's the procedure that you need to follow. Let's do this one. Let's go ahead and continue with another shape. This shape, it's like the sister of the rectangle. It's looking pretty much the same. It looks very familiar with the previous one with the rectangle, but it's kind of off, kind of weird. But you know what? It's the same deal. It's the same thing. And I'm going to show you that it's exactly the same thing. If you notice here, well, okay, before we go into that, let me just tell you that the parallelogram, which is this shape, it's pretty much a rectangle, but it's slanted. It's called parallelogram because this side and this side are parallel to each other, and this side and this side are also parallel to each other. So they're all parallel. That's the only thing that is in common between them. But you know what? It's pretty much the same thing as before. Now, to get this area, you need to know the height, not the side of this thing, which is what you would need when you have a rectangle. But you know what? This is going to give us the same area as a rectangle, and I'm going to show you. I'm going to show you right now why this is the same thing as a rectangle. Now, let's imagine that we cut this part, we cut it up, we cut it. That's a triangle. And then we cut and paste it over here. We paste it right there. Imagine that it's right there. You know what? You don't need to imagine it. I'm going to write it right now. Here you go, through the magic of computers. Computer presentations. There you go. And okay, it's pretty nasty, but let's imagine that this triangle, it's right there. And I also erased this other triangle. There you go. It's not there anymore. Imagine that it's not. What do we have now? You know what? I'm going to show you right now. This is now a rectangle. There you go. It's a rectangle, guys. Surprise! A parallelogram, you get its area through the same formula. Base times height. So you get your base, which is 15. You get your height, which is 9. Multiply that. That's your answer. Let's continue with this other guy called the triangle. Now the formula for the triangle, you guys know it already. It's base times height, but then you divide that by 2. Why do you think you gotta divide it by 2? Well, I'm gonna show you. Basically, it's the same as a rectangle. Imagine you got a rectangle right there. There you go. That's your rectangle. And you want to get its area. What do? You multiply the base times the height. There you go. That's the formula. And let's imagine then that we're going to take this rectangle and then we cut it in half through the diagonal, just like that. What do you have now? This, my friends, is a triangle. So geometrically, you cut it in half, but mathematically, you divide it by 2. And when you cut it in 2, you get this shape, which is a triangle. So that's where the formula of the area of the triangle comes from. It's the same as a rectangle, but you cut it in half. Now you got a triangle. You do the same thing with the area of the triangle. Let's go do a problem. Here's a triangle that's a little bit like the other one of the rectangle, where you're looking for one of the sides and not the area. They gave you the area and you're looking for the other part. So what we're gonna do is apply our knowledge of algebra to this problem. So we have a triangle that has a base of 6 feet. Can you imagine it? Can you imagine that triangle, guys? If you can't imagine it, what if we draw it? Do we draw it over here? Let me see if we have a triangle. Let's see. There you go. There is your triangle right there. If you can't imagine a triangle. There you go, guys. Triangle has a base of 6 feet. Oh, there it is. We have 6 feet right there. And the area which is inside of this triangle is going to be 12 square feet. Now we use square feet, or we can place ft to the power of 2. Just to note, it's the same deal. Alright, the question is, what is the height of the triangle, which is this much? What's that going to be? Well, the area equals base times height divided by 2. But we're looking for the height. What do? We got to go backwards. Remember here we had to divide by 2? Well, now you got to multiply by 2. We got to multiply this a by 2. Remember this h? And it's, well, this b, it's, remember that b and that h? Being multiplied, what do? Gotta go backwards. You gotta divide. So you have 2a divided by b. That's gonna give you your height. So here, when you want to get the area, the height, you gotta multiply it by b and then divide by 2. But now when you want to get the height, you go backwards. You gotta multiply the area by 2 and then divide by the base. That's what you do to get your height. And if we use these numbers, you know the area, it's 12. We know the base, it's 6. 2 times 12, 24. Divide that by 6, you get 4. The height is going to be 4 then. Now let's go with this other shape, which is like a triangle, but without the top. We call this the trapezoid. And the formula is going to be very easy. You got to do a plus b. Well, this a represents this side, and this b represents this other side. I'm going to call it in another way, in another part. And the height is going to be this height. And you got to divide that by 2. So it's basically the same as the area of a rectangle, but you got to get the average of the two bases. We're going to get into that. Now, the trapezoid, maybe you're not very familiar with it, with that name, but I do know that you are very familiar with these things. A popcorn container, you know what? That is a trapezoid. This lamp, trapezoid, part of the ring, that's another trapezoid. You want to see another example? Go to Tenochtitlan or wherever. That pyramid, trapezoid, guys. It's a big trapezoid. And you know where else you can find a trapezoid? Go to your pocket, open up your wallet, get one of these. You know what? That's a trapezoid right there. Scary, right? They're everywhere. I mean the trapezoids, okay? Let's continue over here. Okay, we have this trapezoid with a height of 6 feet and a base of 9 feet. You know what? This is also a trapezoid, but we call this a right trapezoid because it has a right angle. But you know what? It's also a trapezoid. This base and this base, they're different. So what do? I like to call this little base and I call this big base. So what I have to do is just add little base with big base. I add them and then I divide by 2. Then you gotta multiply by the height. Basically, it's the same as the rectangle, guys. It's the same deal. You gotta multiply your base times the height, but since you have 2 bases, you gotta get the average. Which one should I use? Should I use the big one? Should I use the small one? Let's use both, but let's use the average of both. So it's the same as the rectangle, base times height. But the base, since you have 2 of them, you gotta put them together through the average. Let's continue with the area of the circle. The area of the circle is going to be pi times radius squared. You may be like, teacher, but isn't this the same as the other formula that you just showed us a while ago? Isn't it the same? It's not the same because that 2 right there, see that 2? That's the square. It's not times 2. It's not the same. It's not the same, guys. Okay. Gonna put this. Uh-oh. Can't put it. Oh, let's put that right there. There you go. Well, it's not the same. Let's compare them. You get 2 times pi r when you have the circumference, but with the area, it's going to be pi times radius squared. Remember, guys, times 2, multiplying times 2 is not the same as getting the square of a number. So 2 times 5 is 10, but the square of 5 is 25. It's not the same, all right? You just remember that. So they look pretty much the same. This 2 multiplies, but this one is an exponent, alrighty? So that's how you get the area for the circle. Let's move on. Let's go to a problem that's a little bit more complicated. A little bit, not too much. Don't worry about it. Okay, so let's say we have a problem like this one. If the radius of a circle is 24 inches, what is the diameter? Basic, guys. This is piece of cake. It's a piece of cake like the piece of cake that I showed you a while ago. What did you do here? You see the radius? It's 24. We know that the radius is the half of the diameter, or that the diameter is the double of the radius. What do? Just multiply that 24 by 2. You got 48, guys. That's it. You're done. Let's go with the next problem. It says the diameter of a circle A is 10 inches. What is the area of circle A? Okay, they gave us the diameter. Then what I have to do is I gotta change that diameter. I can't go directly with the diameter with our formula for the circle of the area, for the area of the circle. I gotta convert my diameter to radius. What do I do to change diameter to radius? We know that the radius is the half of the diameter, so I gotta divide my diameter by 2. So 10 divided by 2, of course, is 5. So I gotta get the square of 5, which is 25. Then we just multiply by 3.14, and it's gonna give us this result over here. That's what you do, guys. Let's go with number 3. This one, I like it. It's challenging. It's a little bit challenging, which is gonna make you think a little bit more. It says here, a circle has a circumference of 314 feet. That's the circumference, that's the perimeter of the circle. Can you imagine that? Okay, so that means that around the circle, you have 314 feet. But you want to know what's inside of it because it's asking for the area of that circle. What do? So I take the circumference of my circle, and then I gotta get the diameter. What do? I gotta apply my algebra. So you see, pi times diameter gives us the circumference. All I have to do is just divide the circumference by the pi. So I take the 314 and then divide it by 3.14. That's going to be my diameter. But of course, as I said a while ago, you can't use diameter directly in your equation. You got to convert that to the radius. So I divided that 100 and I got 15. That's going to be the radius. What's going to be next? We use our trusty area formula for the circle. We got to multiply that 50 by itself because it's going to be 50 squared. Multiply that by 3.14. You get your result. Alright, let's continue. Let's do this other problem. It says a radio station, WPCS, listen live, got coverage on everything, can be heard clearly for 100 miles in all directions from its transmitter. How many square miles does this station serve? So I don't know if you know a little bit about radio antennas, but you know these antennas of a station transmits its information, its channel or whatever, its music in all directions um, with the same intensity. That's how they work. And the question is, what is going to be what's going to be the area that this radio station serves to? So I don't know if you ever had a very long road trip where you reach a part where you have a certain radio station, but then after a while, you can't listen to it because now it's all static. I don't know if you've noticed that when you go on a very long road trip and you're listening to a really good station, but then you lose it and then you have static. You don't have any more music that you like. And then you gotta wait for the next uh, city or whatever, right? So let's say the car is passing through here, you got music, and then suddenly you're out of the radius. Can't listen to any radio anymore. But if you're around this radius, since it's transmitting in all directions, you know what? The area that it's where you're gonna be able to listen to your WPCS station, it's going to be a circle. So when you have this type of problem, you're actually looking for the area of the circle around the center. And the center, of course, is where you're gonna have your transmitter. Alrighty, so what you have to do is basically get in the area of a circle. So you have pi times radius squared. The radius is 100, so you got to square that, 10,000, multiply. You know what you do. You get your answer. There you go. Let's continue. Now let's go with this other problem. This problem, it's more challenging. It's more interesting as well. This area, this shape, there's no direct formula for this one, but what you have to do is you gotta separate the shapes. You gotta do what I like to call divide and conquer strategy. You gotta do that type of strategy. So what do you do here? Look at it. Look at that thing. That's like a house, right? Does it remind you of your house? That's where you are right now, I hope. Anyways, that thing, it's, well, made up of two shapes. Do you see the two shapes? Do you see those two shapes, guys? Please tell me that you see them. This shape here is what we call a what? Rectangle. That's right. Great job. Now, what about this other one? That is a triangle. Hey, great. I can hear you guys. I know you're saying it. Great job. I'm glad. I'm glad that you said it. Okay, what do we do, guys? What do we do to get the area of this shape? Well, we gotta get the area of the rectangle. We got this formula, so it's length times width. We got the length, it's 30. We got the width, it's 20. Gotta multiply it. Alrighty, guys. Maybe this is an appropriate time to clarify what length and width is. Maybe you were like, what, teacher, what's going on? The length is going to be this part and the width is this one. Okay, length comes from long, from longest. So the longest side of the rectangle, that's what I'm going to call the length. And the other one, I'm going to call it the width. That's how it is with rectangles, okay? That's how we check which one is the length and which one is the width. And of course, that is what's happening right here. If you thought that it was like, oh, this is always the width and this one's the length. No, not always. We can call this the base and the height. It's all relative, guys. You just multiply these sides. Anyways, let's continue. We got length and width. You multiply that, you get the area for the rectangle. You're done. Great job. Now let's get the area of the triangle. What do we do here? We got the half of the base times the height. So you don't know exactly the base, right? But you know what? This is connected to this rectangle. They didn't tell you this length, but since it's connected to this rectangle, this length of the rectangle is going to be the same as the base of your triangle because they're parallel, they're connected, they're the same. So I don't need to do anything else. I just gotta observe it. I gotta do some inspection. I gotta do some inspecting. And this base is the same as this base. So you do base times height divided by 2. That's going to be the area of your triangle. What do you do next to get your house-shaped shape? What do you do to get the area of this thing? You got to add it. You're done. Alrighty. Now let's imagine that we're hungry and we got a donut. But you know what? I want to calculate the area of my donut before I eat it. What do I do? What do I have to do? Well, let's imagine that we have this diagram and we have a huge donut of 5 yards. It's huge. And what's inside of it, the empty space, is going to have another circle which is of 3 yards in radius. That's a delicious donut. That's a lot of donut. Now we want to calculate that delicious donut's area. Do I need to get the area of the inside? Well, yes, because I don't want it. I want to take off this thing. I just want the area on the outside. So what do? We notice that a delicious donut is a circle. We got a circle on the outside and we all the way on the outside, and we also have a circle on the inside. The circle on the inside, that's empty space, which we don't want. And when you don't want something, you take it out, you put it away. Mathematically, what do? What operation do you do when you don't want something? What is it? That's right, subtraction. Gotta subtract now. So before, when you wanted to have the ceiling part of this house plus this wall of the house, you had to add. But now we're gonna do a subtraction. So what do? I gotta get the area of the big circle, which is this. They gave us the radius of the big circle, which is this 5. Multiplied, it's the same as the other problem. We did that before. And then we gotta get the area of the empty space. This is not part of the donut. You're not gonna eat this. There's nothing there. I'm sorry. So we got 3 squared, which is 9, multiply by the pi, 3.14, get 28.26. What do we do next? We gotta subtract because this is a circle made up of empty space. That's not donut, you don't eat that. You gotta subtract it. That's it. That's what you do. And that's gonna be the area. So this is gonna be the area of your donut. There you go, you can eat it now. Let's continue. Now let's say that we have this field of grass. This field of grass has a length of 225 feet and 75 feet. That's the whole lot. That's a big lot, guys. You can farm in there. You can have your chickens and your cows and whatever. And let's say that you have a house and a workshop where you can build things. And the question is going to be, what is the area of the grass field? How much area is going to be this green part of this rectangle? What do we do? I don't want to get the grass inside the house. I hope there's no grass inside there. And also, I don't want to get the grass inside the workshop. There's not going to be any grass in there, okay? So I need to get the grass on the field. What do I do? Well, basically it's the same strategy as before. The donut, delicious donut. There you go. What do we do? We gotta get the area of the lot. You know what? This lot has a shape of a rectangle. So what do we do? Just multiply the length with the width. This times this. So you get this amount. Now let's get the area of each of these little shapes, which are also rectangles. The house is having a shape of rectangle, so we gotta multiply the length and the width. Gives us this. The area of, wait a minute. This is not the house, this is the workshop. There you go. And then you multiply that, and it gives us this. What do we do next? Well, we got two parts that we don't want, which is the house, and we got another part, which is the workshop. Now we gotta subtract it from the lot. And you get your answer. There it is. Let's continue. Now let's say that we have this crazy shape, and it's an arch shape or whatever, and we want to calculate this part that is colored. Why? Because we love mathematics. That's what we do. So what do we do? Okay, we have here notice here that we just got this length. It's 14. And it didn't tell us anything from here. But since it's inside of since it's on the outside of a circle, then this side and this side have to be exactly the same. So this is going to be 14. 14, guys. And 14, and this is 14, so that means that this is a square. What do? We gotta get the area of the square. We gotta multiply 14 times 14. That's it, you get your area of the square, and then we get this circle, which we don't want. We don't want it. What do you do when you don't want something? In mathematics, arithmetically, what you do is subtract. But before we do, we gotta get the area of that circle. So we need to know the radius. This is 14, and the half of 14 is 7. So that means that the diameter is 14. The radius is gonna be 7, which is the half of 14. Now what do we do now? We gotta get the area of that circle, which is this amount. What's gonna be next? I gotta subtract the area of the square minus the area of the circle. When I subtract, I get that. And you know what? You know what, guys? We are done. We're done. And I wish you to have a great day. So I'll see you next time.